GitHub also?
Oh,
Is that if you have time?
yeah, if you have time.
No, not always. Just whenever I see you.
Hey guys, is the mic working?
Yeah.
Okay, awesome. So we are welcome back, I guess, to another lecture. We're going to be going over deployment, so how we can deploy our apps on the cloud, and if we have time, we'll go into some like GitHub basics and stuff like that. Okay, so before we have some administration-related notes. Hack Challenge midpoint meeting should be this week from Wednesday to Friday. If your TA does not, I believe all the iOS TAs should be reaching out. So if they don't reach out by Wednesday, just make a note in the Hack Challenge Piazza, which you guys should all be on. If you're not on that, is anyone not on that? Can you just raise your hand if you're not on it? Okay, awesome, great. And PA 5 grade should be out by Wednesday. Okay, and some other announcements. Ithaca Transit is releasing on Android soon, and we're looking for beta test users. I'll post a link to this on Piazza after the class. But if you're an Android user and you want to try out the app, yeah, you can just follow the note. We'll also offer extra credit for that. And the last announcement is Eatery now has College Town Eateries. So this is on iOS and Android. It's out on both. Awesome. Okay, yeah. So it's out on both. You can see all College Town Eateries, I believe, and you can like use all the normal filters. You can see when they're open. These are like the Yelp reviews, etc. So you can check out that update if you haven't already. Okay, so what can we do so far? This has been sort of like a recurring question, I guess, throughout the semester. So just kind of like a recap, we went through data structures, so kind of storing stuff in the memory of the application that we were running. We went from there to interfacing with SQL directly through Python, which looks something like this. We had like a client that would connect to a Python app, which is running Flask, and that would use SQLite to connect to the database, and we wrote the SQL queries directly. And the last step was ORMs, or object relational mappings, and that's what you guys have been working with for the last few assignments. Kind of a really intuitive syntax that lets you define classes for each of the tables in your database, and then defining the fields pretty intuitively, I think. So some of the things that we didn't do, something that we didn't cover in this class is like splitting up architecture into like a lot of different files, I guess. So I can just show you guys an example of that. So right now we have something like a routes.db or routes.py file and a models.py file, and each of those files has basically all the routes and then all the models. In an actual like application, you probably want to split those up, and that might look something like this. So this is just the Eatery backend code. So all the models are grouped. It's not exactly like a one-to-one in terms of each file has a specific model, but related models are grouped together, and that makes it a lot easier to read through the code. So if you think about it, if like in the context of the class, we only have like 3 or 4 models, but maybe for the hack challenge, your database is pretty complicated and you have a lot of different things that you want to store in your database. In that case, it might be better to actually split stuff up into different files, and then you get an architecture that looks something more reasonable, I guess. And the last thing that we did not cover in, I don't know why that animation was so slow. The last thing that we did not cover was deployment. And so this is kind of goes back to Docker, which we talked about 2 lectures ago, which is a long time ago since it was before spring break. So I'll give you guys a brief refresher on that. Oh, actually, before we go into that, does anyone have any questions? Okay, awesome, great. So Docker, if you guys remember, is a container platform that allows developers to package code into a unit of software. Super useful, but the most important thing that you need to remember about Docker is we have images and containers. So images are what we use Docker files for. It allows us to build sort of like a package of software, and then a container is just a running instance of that image. So we have the definition of an image here, which is just pulled from the Docker documentation. And some helpful analogies just as a refresher. You can think of the relationship between images and containers like classes and objects in Java, or blueprints and houses, or recipes and cakes, right? Perfect. So we're going to get into deployment. We're going to use Docker. The first thing that we're going to do, so you guys should all follow along. We actually don't have enough credit for every single student, I believe. So if you're here and like you're sitting next to someone that you're working with for the hack challenge, that person should do it, and then you can just like help them if they run into any things, I guess. Yeah. Okay. Awesome. Okay. So we'll get started. So I posted the link on Piazza. You can just go into click on this link. So the student coupon retrieval link. So if I just open this in a new tab. Oh yeah, and you guys, this is the deployment step is required for your hack challenge or the hack challenge project, so that your iOS developers can interface with it. So it would be very useful for you guys to follow along. So if you click on that link, you should get a page like this. You should just fill this out, and you should get a link to your email that you fill in here with some Google Cloud credit. Yeah, what's up? Yes, yeah. So if you get that email to redeem it, you should just redeem it. Yeah. If anyone is having issues with this step, you should just raise your hand. And I'll give you guys another minute. Yeah, it's you don't see the link.
Did you get an email from Google?
Wait, no, the link is right here. Wait, you don't see the...
Piazza?
Oh, okay. Did you have like Google Cloud Card for a different class, possibly? Okay.
Is it different email?
It has to be Cornell. Do you have credit that you would be able to use for this class? Or like, is there not enough credit? Okay, yeah. If you're still having issues with the credit, you can talk to us after class, because we do have like other coupons. Does anyone else have any issues with this? Okay, great. So if you should get like a link, something like this. If you click on the redeem link, it should be like Google Cloud Platform. I'm not sure if this is exactly what you guys will see. You guys will probably not have a project, so you can just click on New Project. So, great. So I can just call this, so the billing account should be like CS 1998 or some variant of that. For the project name, you can put whatever you want. I'll just put like Lecture 7 Demo or something. And you can just press Create. That should probably take a second. And once it's finished, you should be able to select that project from this drop down up here. So it'll take a minute to create. This notification thing in the upper right should give the status. Yep, so I can see that it was just created. And now I should be able to click on the project, and it should open that in the Google console. Okay, is everyone up to this step? Does anyone need another minute? Sorry, was that a hand in the very back? Okay, yeah, well, we can wait a minute. So the link to the credit is in the Piazza note, and then if you fill that out, you should get an email. And then from the email, there should be another link. And then when you press the link, yeah, you get the credit, and then you can create the project, which you can just do from right here. Okay, so from there, we can go into compute. So if you press on this left sidebar, the navigation menu, and scroll down to compute engine right here, you can press on VM instances. So if you click on that, so just to refresh, you press on the navigation menu, scroll down to compute engine, and then click on this. Yep. Okay, and then it'll take a minute to get ready, I guess. So what we're going to do is basically deploy, we're going to take our code and then run it on an external server, which is going to be running on Google's cloud infrastructure, and it's going to be running in a virtual machine on it. Yeah, so hopefully this will get ready soon. Actually, in the meantime, we will do something else. So if you go back to the Piazza note, I linked to some starter, or not starter PA5 code, but starter PA5 code for this demo. So you can just download that. And this is just a solution for the last assignment. So you'll probably get something like that, a source directory. So I'm just going to go into my downloads and cd into that directory. And you should see if you run ls, if you run ls, you should see the contents of it. And you can open this directory in whatever editor you want to. I'm just going to stay in the terminal and use a terminal-based editor. So you want to create a Docker file here. And so this is where Docker will be involved. So just to show you guys what this is, if I get out of my virtual environment and I create a new one, okay. I can run the test script, which is the same one that we gave to you guys for the last project. And we can see that it's the same application. It's just taking a while because my computer's really slow while recording. But we can see that the test finished. And so we're going to make a Docker file in this directory. And this is going to let us build an image that basically represents the contents of our application. So we are going to start from Python 3.6. So this is just a tag of an image that's available online. If you guys remember from the Docker lecture, we can build starting from other images. So that's exactly what we're doing here. We're going to copy the contents of our current directory into the root of the image. Sorry. From there, we will run pip. We'll install the requirements inside of the Docker container. And the last thing, which is the cmd keyword, this is a command that you specify that will start when you actually run the image. So this is all instructions to how to build the image. So if you think about like the recipes and the cake analogy, this is the recipe. And then the command, the cmd, the last keyword is just like running or like baking the cake, I guess, after you've finished all the instructions. And that's just going to be Python app.py. Something else that is going, so I'm just going to write and quit, just WQ in Vim, but you can do this in whatever editor you want. Another file that we want to have is a docker ignore. So this tells us what files to not include when we copy in the previous copy instruction. So we want to ignore our virtual environment and the PyCache directory because that has a lot of files that we actually don't need for the building of the image. Okay. All right, so let me check back on whether Compute Engine finished starting up. Does anyone have any questions in the meantime? Okay. Okay, so if we're on the screen, we can press create. So we're going to create our virtual machine, or sort of like what we can think of as our server. So we can call this whatever we want. I'm just going to call this demo. The region should automatically default to US East. But if it isn't, you should just select a region. Any of the East regions would work. And for the machine type, we actually don't need something with a lot of compute power, so we can just select one of the less expensive ones. So something like the small would, or the small preset, that would be fine. And then we can see what the cost is on the right. And for the boot disk, we're just going to change this to, so this is a startup operating system. We're just going to change this to be Ubuntu 18.04. Okay, so, and the last thing is you want to make sure that you check this, allow HTTP traffic, because this is how we'll be interfacing with the app once it's deployed. So just to reiterate, you can name it whatever you want. Region should be in US East. You should change the machine type to be small, and the boot disk to be Ubuntu 18.04. Okay, awesome. So then you can press create. Is anyone not up to this step? Okay. Do you need a minute to catch up, or?
I just had like an issue with like the first step, so we'll just like figure it out later.
Okay. Do you want to?
Yeah.
And was anyone else having issues before the step? Okay. All right. So if you're on this page, you can just press connect over SSH. So you can just press this button, and it should open it in a new tab. So you should see your net ID at the IP of the machine that we just created. Okay, so you should see something like this. So I see my Gmail address. I'll try and zoom in here. Perfect. Okay, so you should see your email or your net ID at the name of the instance that you created. And then you can click on this. So this link to a tutorial that's going to let us install Docker on a host. And if once you're on this page, you can scroll down. So there's two like prerequisite tutorials that are linked. We're just gonna click on the second one. So if you, oh, okay. So it says we can just follow steps 1 and step 2. We actually don't have to worry about the firewall and some other steps that are in here because Google actually already handled those when they were provisioning the server. Does anyone have any questions? So the Docker tutorial is linked from the same Piazza note. If you go to it and you scroll down, we're only going to be following the second bullet point, and you can just click on this link. And I'm just going to be copying and pasting the steps from steps 1 and 2. Okay, perfect. I can actually paste. Nice. So explaining some of these steps, sudo is just running the commands with root privileges, which we actually don't need. If we look, oh no, we actually do need these. So if you look here, this is a $sign. This actually has significance. This says that we aren't the root user. The root user would have like a hashtag or a pound symbol at the end of the prompt. And right before this, the tilde signifies that we are in like the home directory of the user. I'll continue running these commands. Okay. When you're given this prompt, you can just press Y for yes. So apt is the package manager on Linux, and we're just saying, oh, install all of these packages. Okay, yeah, I'm just going to be copying and pasting these over. Cool. So basically what these steps do is we're adding, so as any package manager would, it has a list of packages that you can install. This specific, or like the Docker installation that's available from Ubuntu, as it says up here, may not be the latest version. So to get the latest version, we add the kind of like, we point the package manager to this Docker repository where we can get the latest package of Docker, or the latest release. Let me check what command I'm up to. Did I do this one? Yes, okay. Oops. You can skip this step unless you got an error. This is just verifying that the Docker package is pointing at the correct place. So now I'm going to install Docker. Again, you can just press Y here. And this last step, which is over here, tells us whether or not Docker has started running, which it is. So we can see that it was a success. Nice. And you can press Q to get out of the previous prompt if you get one after you run the systemctl command. Okay. From there, we can actually also skip step 2, actually. Since we already have a default user. And we'll just run the Docker command with sudo just for time's sake. But if you completed that step, that's completely fine. Okay, so next we're going to install Docker Compose. So if you guys remember, Docker is just a software that lets us run applications that are built with Docker. And Docker Compose gives us a really nice interface to be able to do this in a more clean way, if that makes sense. Hopefully this will make more sense after we get stuff running, but you can just think of these as like the setup steps on a server, like installing a new program or something. Does anyone have any other questions? Or is anyone not up to this step? Okay, great. I will take that as a yes. Okay, so this last command will let us check whether Docker Compose is installed, and we can see that like we're all ready to go. So if we type Docker and hit enter, we get a whole list of things that we can run, and this just verifies that Docker has been installed properly. Okay, so now that Docker has been installed, the next thing that we want to do is give Docker an image to run, right? So we want to have a container on this server. So we can go back to what we were doing before in this source file, and I'll just put up the Docker file and the .docker ignore. So if you guys are looking at the very bottom, you can see that, I'm not sure if you can actually see that, but over here, you can see that this file starts with a dot. The dot is pretty significant, so make sure you don't forget that. And on the left, this is just Docker file. And this is in the same directory as the zipped file. Okay, so from there, we should be able to run docker build and -t. So we're going to tag the image, and I'm just going to call this lecture 7 demo, and we're going to specify the build directory, which is just the current directory. So if we look at the build context that was sent to Docker, we can see that it's really small because we ignored the two largest directories inside of this directory.
What's the significance of tagging didnt?
Yeah, so okay, so tagging it'll be more apparent why we do it, but like it allows us to kind of keep track of images. So all of these images have hashes, which we can see right here. But then if we don't tag it and you're building a lot of different images, it might be difficult to keep track of like what corresponds to what, right?
It's like basically naming something so you remember what it does
Yeah.
later. It's like giving like an alias, basically.
Any other questions? Okay, hopefully this step completes, or this whole thing runs. I'll probably find out after you guys because my computer is so slow. But okay, so it looks like it built correctly, which is a good start. We can test whether this is running or not by running the following command: docker space run space -it. This lets us just command C out of the program if anything is broken. Wait, let me focus on this. Docker run space IT and then lecture 7 demo. Hopefully this works. Okay, great. So it looks like it's running. I don't know why there's an echo, but that's okay too. So if I go to localhost :5000, we get this can't connect error, which is expected because if you guys remember from 2 lectures ago, okay, I'm gonna load this. If you guys remember from 2 lectures ago, we have to add a -p flag, which specifies the port mapping. So Docker containers are running in, I'm just not going to use this. Okay, so Docker containers are running in, wait, how is this echoing? Wait, it's off. Wait a second. Huh. Oh, it's probably this. Hello? No, it's not it. Okay.
Is there another mic?
Yeah, I have an idea. Hello? Oh, amazing. Okay, great. Okay, so I'll use the mic. I'll use the mic. That's not good. Okay, anyways. Okay, so we can specify this port mapping. So if you guys remember, we have the Docker container, and that's running within Docker, and that's running in like its own separate machine. So we have to specify like, oh, if it's running on port 5000, map that to port 5000 on my computer, which we can do with this command. So now if I run this, is the mic working?
I think so. Yeah.
Okay, awesome. And now if I go back and I go to localhost 5000, I can see that, wow, I can connect to the app that's running in Docker. So this still is not exactly what we want. We still have a few more steps. So in the Docker lecture, we also talked about this thing called Docker Hub, which is really useful because it lets us take the images that we build locally and push them to something like GitHub, right? The equivalent of GitHub for Docker, which is just called Docker Hub. For example, like I can look for Python, so the image that we built from in the Docker file, I can just print the contents of a file in the terminal with the cat command. We have this thing from Python :3.6, we can see that Python is a Docker, if this thing would close, is a Docker repository, and 3.6 is just a tag that is available somewhere here. There's a lot of 3.6 tags, but that's exactly where we're pulling the image from. So you guys should register for an account here. I'm already logged into an account, but let me see. Yeah. So you guys should register for an account on this website and create a Docker Hub account. I guess I'll give you guys a minute to do that. Yeah. Did anyone have any issues with the previous steps or has any questions? You can just raise your hand. Yes. Do you want to? He can't. All right, so does anyone need another minute to make an account? Okay, great. So if you go back into your terminal, you can just run docker login. And for me, it says authenticating with existing credentials. But if you just register for an account, you should get a prompt saying put in a username and password. This should correspond to the username and password that you just filled on this site. And something to watch out for is when you type the password, like your cursor won't move. That's completely normal. Yeah. Okay, great. So hopefully everyone is logged in. The next thing that we can do is if we go back here, I tagged my image as lecture 7 demo. We're actually going to retag this, so docker tag, and the existing image tag, which is just lecture 7 demo, and then your username on Docker Hub. Mine is this, so I'll type that, and I'll put a slash, and then the name of the repo that I want to create. So here it's just going to be lecture 7 demo. And then I can just push this to Docker Hub with that command. So docker push, and then your username slash the repository that you want to create. So since the internet's really fast here, this should only take a few seconds. And then when you go back into Docker Hub and you click on repositories, you should see the repository that you just created, which is right here. Okay, so we're almost done. Now we're going to go back into the tab that was running the terminal session. Does anyone have any questions up to this step? Does anyone need another minute to push their image to Docker Hub? Okay, great. So you can go into this tab that's running the SSH session into your server, and we can run this. So docker run -it, and then I'm just going to put my username, but you should put your username slash lecture 7 demo or whatever you tagged it. So this should correspond exactly to what you put here. So you can just well, you can't copy and paste it, but you should type it exactly. The last thing is we need to specify a port mapping, so -p, and then on the server itself, we actually want to run it on port 80. So this should be 80:5000. So 80 is just the port that all HTTP requests are served on. HTTPS is served on like 443. There's just different ports for different things. But 80 is just the convention for HTTP. So we can just run this command. Okay, perfect. It's because I forgot to put sudo. So if you followed the Docker tutorial over here, there's a step executing the Docker command without sudo that I did not run. If you ran it, then this above command should have ran fine, but for me it did not, so I'll just preface it with sudo. So it says unable to find this image locally, which makes sense because I built it on my computer. This is on the server itself. So it actually pulls the image from Docker Hub, and all of these, so these are actually like layers of the image. So this really is like a cake. It's like layers of the cake, right? And then, yeah, so hopefully this finishes soon. Does anyone have any questions while we're waiting? Great. So if we go back into this tab, so where we had this, we can actually copy this external IP. So this is just under VM instances. If you're not on this page or you close the tab, a reminder that you can just go there by going to Compute Engine and then clicking on VM instances. Awesome. Okay, so it looks like stuff started. I'm going to copy and paste that IP in, and wow, it's amazing. Hello world. It's exactly what I had running on my computer, which means like we had code that we were running locally, and now it's deployed so that anyone can actually interface with it, right? And so this IP address is public. We can actually set up more like rules around like who exactly can access the IP. I actually think I'm not sure. Yeah, there are definitely security rules that you can set up so that only specific clients can access it. But yeah, this is basically that. So now we're going to go into some more details. So one of the annoying things here is that, so we can see that the requests are being served as people hit this endpoint. I think this is someone else because like the IP address here is different from the one that I just said. What's next? Okay, so one of the annoying things here is that what would happen like if I close this tab, right? Like when my program stopped running, like it's pretty unclear what would happen. I don't want to have to like keep a tab open on my computer just to run the program, which is why we use Docker Compose. So if I just Control-C out, I'm actually going to create a Docker Compose file. We will use Nano, which is a editor that should be installed here. So this is like a really primitive editor. It's really ugly, not what we're used to, but it's okay. It does the job. So let me find a Docker Compose. So okay, Docker Compose. So I'll refer to the documentation just because I want to make sure I get the syntax right. If you want to change your Docker Compose file, this is just like the Docker documentation is fantastic. I would definitely recommend looking at that. So, okay. So first we have to specify the version. So I can just type version : let me just check that. It's just open quote, close quote 3. And next I'm going to have some services. One of the annoying things is that this will not tab for you, so you'll have to type out the spaces manually. So I can just name my service. I can call it just demo. And next up, we want to specify, we actually don't have a build directory because we're pulling it from an image. So I'll just put the same image that I put before, which is my weird username followed / the name of the repository and the port mapping. So the port mapping is just 80:5000. And I think that's all we need for now. Yeah, perfect. Okay, so to exit, you can press Control X. You can see this right here. So Control X, save modify buffer. You can just press Y for yes, and it just double checks that you want to write to this file. I can press Enter, and now if I run ls, I can see the contents of my server and see that there's a Docker Compose file. To read the contents, I can just run the cat command that I ran earlier in my terminal, and I can see that it's exactly what I want. Okay, so with Docker Compose, we actually don't have to run the previous command that we wrote where we had to say like, oh, this is the port mapping. We have to do all of this stuff. If you note, like all of that is actually noted in the configuration of this file, which makes this really useful because as configurations get more and more complex, it allows us to just store it in a file, and like maybe we could just have this file on GitHub, right? And it's very clear to everyone exactly what we need to do to run our app in production. So I can just do Docker Compose space up, and right, we need the sudo command because I didn't follow that second step. So we get similar logs. If you note that, like here we didn't have anything on the left, but here it says like demo_1. So Docker Compose has a lot of nice features. Like we can run multiple instances of the same application. So like, oh, we can like load balance between different applications, right? It comes with a lot of features, but hopefully if we go back to the same IP up here and I refresh, it's working, just to verify that like it's actually running on the IP. If I stop with Control-C, okay, hopefully it'll stop soon, but you never know, I guess. See, it does. I get a connection error. Okay, so same thing. This didn't really solve our problem where we wanted to kind of like run a command and then have it running indefinitely, right? So we can actually say, oh, run this command in the background. So we specify this with a flag -d. We can also write like -help, I believe. And we get a list of all of the flags, right? So D just stands for detach. This actually works on like most things that you run in terminal or on servers, and you can get really nice, helpful messages if you're ever unclear like what something actually refers to. So I can just put -d or -detach, and it starts in the background, so I don't get any of those logs. Some other things that are useful to see, we can run Docker images. I need to preface this with sudo. This lets me see that, oh, I have this image here. What else? I can see all my running images with sudo docker ps. So this says that, oh, this image is running. And so now if I refresh, bam, it's running. And I can close this tab and it'll work fine. So something that you guys will encounter in your hack challenge projects is like, oh, I updated my code and I want to update the code that's running on the server so that iOS can actually work with it. Like, that's a totally normal problem that you guys will definitely run into. And you want to kind of like deploy your code onto the servers often, just so that like your iOS developers can always work with the latest changes in your code base, right? So how do we actually do that? So let's say I go into my app.py. So you can open this in whatever editor you want. Just to clarify, I'm in that same source folder that I downloaded with the the Docker file. I'm just going to open up app.py in my favorite editor, but you can open it in whatever editor you want. And I'm just going to write hello world 2 or something. I don't know. I'm not very creative today. So you can write and save this. So I just saved it. I can, again, just run cat, and I get this whole dump. But if we scroll up, I can see that it's, oh, hello world 2. Okay, so I can rebuild this image. So docker build -t. Yes, your username. So instead of tagging it and then retagging it, we can just tag it from the beginning so that it's like more streamlined, I guess. So one of the nice things here, or actually, yeah, we can just run this command actually. So there's even more advanced things that we can do with tagging. But if we have time, we'll go back to that. But then if not, we'll just stick with this approach. Does anyone have any questions up to this point? Okay, cool. Yeah, if you're interested in like server-side admin stuff, DigitalOcean has really good tutorials, I think, in general. Like if you're ever trying to install something on a server, these tutorials are like the easiest to follow that I think like I found ever. And usually respond and like get back to me. It's finished. Okay, great. So same thing, I can just push this new image. Docker will recognize that it's a new build, so it pushes this new layer, I guess. It's actually really smart. Like the image itself is divided into different layers, And if it finds that layers already exist, it doesn't actually push those, which is really nice because if you think about it, this application like contains everything that we need to run it, right? So like Python libraries, like OS libraries, etc. And packaging all of those and uploading it every time would be really, I don't know what the right word is. It would be a lot. It's unnecessary, I guess. Um, so we can see that it pushed. If I go into and I click on this repository, we can see that it was updated a few seconds ago. So this is great. Now I can go back here and run sudo docker ps so I can see that my application is still running from this command that I ran a few minutes ago. I can go back into the IP, see that it's actually running. So we actually need to kill our running image before we can deploy a newer image. This is because like if you've ever run the Python app locally and you got an error like, oh, this port is already in use, right? Like port 5000 is already in use, and you're like, oh my god, why is this happening? It's because we can't have multiple programs that are using or listening on the same port. So here we're going to just kill the running container. We can do this by copying and pasting this container ID that we see on the left. You can do this, yes, yeah. So you can do that, or you can, so if we assume it was up, you can also do sudo docker compose down, which actually is the better way to do it that Megan just pointed out. You should not do this actually, but if this doesn't work, then you can do this. Anyways, okay. Oh yeah, and some other stuff that might be useful when you're here is like, you can do Control A to go to the beginning of the line, and then Control E to go to the end of the line. It's also really useful because like you don't want to have to like press arrow key a million times if you realize you made a typo in the very beginning. You can press up and down to go back and forth between commands. And something else is like you can do Control R. So this is like a recursive search. You can see it right here. And I can just search for like run. And then I can see the last time I ran a command with run. Some really useful things that you may or may not use for the hack challenge. But I think it's just really useful to know in general. So next, we can pull the latest image from the repository. So we just do that by doing the same thing, sudo docker pull my username / the repository name, and it only pulled the latest layers. So we got the latest image, and now we can do docker compose up and -d. I also forgot sudo, so I can do Control A to get to the beginning and then type sudo. Nice, perfect. Yeah, what's up?
Sorry if you already said this. I was just wondering. So did it like the container that was like the A2E1D hash that?
Yes.
Is that like the old one, and did it lose its tag because we gave the same tag to the new one?
Okay, so container IDs and tags are different. So IDs are just unique for every container, and then like the tag here is sort of like the image that it's referring to.
Oh, that's one. Sorry.
Yeah. If I zoom out more, then like this would all be on one line. It's just because like it just gets really ugly when like everything's on the same. Yeah. Okay, so now if I refresh this, I see Hello World 2. So this is like kind of like the full life cycle, right? I deployed the app, I updated it locally, and then I am able to update what's running on the server. Any questions? Yeah.
In practice, would there be a way to like do this automatically?
Yeah, so that's a great question. So like on AppDev, when we were doing like deployments to our servers, we have like varying levels of automation. So like, oh, if I push to like master, like the master branch on a GitHub repository, deploy like the newest image on the server, right? So I think, yeah, so like in practice and in industry, it gets like even more automated than that, right? But this is sort of like a good introduction, and I think like understanding how it would be done manually is, yeah, before automating is really important, exactly. Any other questions? Okay, I'm not sure what else we can cover in 8 minutes. I guess I can talk a little bit about some other useful things that you might encounter. So something that you might have is like, especially if you're implementing authentication or have like some sort of like client secrets, is like, oh, I might have like an environment file in this repo with some secrets, right? and I don't want to push those to GitHub, but I want some way to access those in my Docker file. So kind of let's like accelerate what we've been doing. And so I'm just going to create a secrets.n file in my source directory. And I'm just going to set like a secret equal to, or maybe like, let's make this more realistic. Like it's like some Google client ID that I generated for authentication. And this is going to be like some secret thing, right? So I created that secrets file. I'll just leave that up if you want to follow along. Okay, hopefully my terminal starts. If not, I'll just close it. Okay, great, perfect. I'm gonna go into my app.py, and I'm just going to import a package that'll let me access environment variables. And now instead of returning hello world, I'm going to return my Google secret, which you should never do in practice. But I'll do that here. So I can just, I think I called it Google. Let me double check. Google client ID, okay. Google client ID. And I think this should work. I'll just double check it. So I'll just run python app.py. I'm not sure. Wait, do you think I did? Oh, okay. Yes, I did not delete this line. That's important. Okay, so I'll run my app. Perfect, it's running on localhost 5000. Let me just double check that it's actually returning what it's supposed to. Oh, that's not good. Okay, let me, yes. So I can source that file into my environment. So this is just a way, so if you had like secret stuff that you did not want to commit to GitHub, you'd usually just store them all in a file. And you can source it to just like temporarily bring those changes into your shell. And then so when I run this and I refresh, not good, not good. This is not good. Let me see. Did I spell something wrong? All right, this is really a mystery. Google client ID. All right, we're just going to assume that this worked, which you guys should not do. But I'm going to rebuild my image and repush it. And so assuming that that all worked, we can actually add some more flags in this Docker Compose file. Oh, wow. Oh, it's because I opened it in Vim. Okay, we're not doing that. We're going to open it in Nano again. So if I open this in Nano, I can actually specify an environment file. So if I go back to the Docker documentation and I just search for environment, so I can do that through this. So environment file. So again, I can do Control E to go to the end of the line. Super useful. And I'll refer to this. I did Control X. I want to save and I want to write it to that file. And I'm going to create a secrets.env. So you can delete the line by actually doing Control A and to go to the beginning and then doing Control K. And I'm going to do the same thing here and hopefully it will work. There's only one way to find out, I guess. But so I wrote to that file. We can just verify that it's correct. Okay, awesome. And okay, so I want to push this image to Docker Hub. So if you guys are familiar with GitHub, this is like something that I might have in a git ignore. So like in your project, if you have any secret files, and since the submission will be through GitHub, you want to have those files like locally stored securely, and you don't want those like where anyone can access them, right? So I might have them in some other file. And so this is just an example of like how you might access that if this works, which it might not. Okay, so I push the image. I can pull the new image. I'm going to run docker compose down. And once it stops, oh, if it's taking a long time, you can just Control C. Okay, wait, it didn't work. Okay, you can't do that. Sometimes it'll say like, oh, if you Control C again, then it'll like kill the image, but it didn't work that time. Sudo docker compose up. Yep. If you notice, I didn't run the dash detach flag, and that's why I got all of this log output. But if I run this, I get the secret. So this is how you would do this. I'm actually unsure why the environment sourcing didn't work locally. But yeah, that's sort of like a quick demo of how that might work. So I think that's it. Does anyone have any last questions? Yes.
So on here we did like you made a Docker file and it was like pretty simple, and then
Yeah.
we made like that what was it again, like the Docker build file or whatever, like
Yeah.
the one that had a configuration in it.
Yeah, so the compose file is on the server, yeah.
And then for all of our projects, when we've just been doing everything locally, we have like the Docker, like we have like the whole like VM folder with like the Docker file and like the VM run file that's like looks like some script.
Yeah.
So are we supposed to not use that anymore and make our own Docker, like for our projects?
Oh, yeah,
Should we
yeah.
make our own Docker file and be having like a compose file and doing all that and ignoring and not using like the Docker files that you guys have provided for the other projects?
So when you're running stuff locally, you can still use like the VM, but then when you're like building images, you can do that either locally or inside of the running container. Yeah, so it actually doesn't matter. But like the Docker file that we just went over should be like, it should work for any of your projects unless you have like external packages that you're using. In which case, like, you can just post on Piazza or look into the documentation. I think it's pretty straightforward in terms of like how you would extend an image. But yeah, does that make sense? Does anyone have any other? Yes.
How do you make a Docker file without using a thumbnail?
Without with okay.
If you go into VS Code, like open the folder in VS Code, on the sidebar you should be able to make like new file, and then it'll prompt you for like the file name. You can just type that in, and then yeah.
Yeah, so there isn't anything special about this file. Like I could, okay, I don't think I, like if I was to open this, yeah, in any editor, I can just open the folder. Like, and it's, what I did is the equivalent of just creating a new file in that directory. Yeah. Any other, yeah.
What is a copy dot do again?
Yeah, so this is really useful because it lets us, so like when we're building an image, Docker doesn't put anything in that image unless we explicitly tell it to. So this copy command basically, or copy instruction, tells Docker to move everything from our current directory into the Docker images current directory. So it's similar to the port command where like our port comes first and then, sorry, the container, wait, sorry, I have them mixed up. But it's like similar to that basically, where we're like, oh, copy from here to here, like the port mapping from here to there. Yeah. Any other questions? All right, awesome. People should, or TA should reach out to you about Hack Challenge midpoints. If you have any questions, you can post them. I think posting questions in the Hack Challenge Piazza will get you more visibility now because we have a lot more TAs in that specific Piazza. And yeah, that's everything. Thank you guys.